Okay, so today I'll show you how you can use DataGraph, the datagraph.io platform in order to enrich some data that we have with weather parameters. So this is the dashboard of datagraph.io. Basically, Datagraph is a platform which allows you to manage different types of assets. Um, so you can upload just files on the platform and manage them. We also manage Sparkle endpoints, which are RDF databases, triple stores. Um, data transformations. So these are these are reusable assets that define cleanup and enrichment and RDF generation pipelines. Queries. These are queries that you can define to the managed databases on Datagraph, and you can attach them to the databases and then execute them. So, for example, if you have a Sparkle endpoint and you want your users or the users of the platform to be able to do some standard queries, you can define them and attach them to the Sparkle endpoint and make them public. And then finally, ArangoDB instances, which are multimodal databases. But today we focus on the creation or the data transformation, or specifically data reconciliation enrichment capabilities of Datagraph. So from the Create Assets tab, you can go down and create a new transformation. So today I'll use a predefined dataset that we have prepared in advance. So this dataset contains a bunch of keywords and keywords and impressions. So these are data that were extracted from Google AdWords. And the dataset basically contains for each keyword which category of it belongs to, the keyword itself, some identifiers, and then things related to the impression. So where the impression from Google AdWords occurred. So this is the city, on which date it occurred, how many actual impressions occurred, and then there's this category identifier for each category. So yeah, Datagraph provides you with the tool called Grafterizer 2, and in Grafterizer 2 you're able to create these pipelines. So the first thing we want to do is to define the header of this dataset, and we use that header for applying different functions and different pipeline steps for the different columns. The way we will do that is with this make dataset function, and you have several options here, so you can specify the column names on your own, or you can just use the first row as a header. So in this case, we have a header row, so we can just use that one. Okay. So now that we have that, we can start working a bit on our reconciliation enrichment. So what we want to do in this case is we would like to enrich this data with, or reconcile this data against geonames, the geonames knowledge base, and understand. So as you can see here, the cities, we have data about the cities, but we would like to extract weather per region, weather data per region. So what we'll do is we'll reconcile these strings of the city names against geonames, and you can do that in the tabular annotation tab. So if I go here to the string str city column and click here, this is the reconciliation UI that we have. And we have 3 service groups currently. So we'll use geographical reconciliation, but there's also general purpose reconciliation. So if you have some free text in a column, or, well, this would work on any kind of text. So this Wikifire service would try to identify entities within the column and annotate with URIs for those entities. And we also have this categorical category reconciliation service, which allows you to reconcile Google product categories. But we use the geonames reconciliation. So when I click reconcile, now the UI has identified that, first of all, this is an entity of type ADM4 in geonames, which corresponds to the city name. If I click here, yeah, we go get redirected to geonames ontology. So this is the full ontology. And then here we see the actual reconciled entity. So each of the string and the corresponding entity. And we have successfully reconciled all the entities. And when we click here, we automatically match based on the threshold that we've defined. So whenever we receive a reconciliation answer from the service, it would come with a level of certainty. And in this case, we've set a threshold of 0.8, above which we can assume that we have reconciled correctly. Okay, when I click apply, we will now extend the table with an additional column, which would give us the geonames identifier for each of these cities. If I click here, this would be Kerenberg city in geonames. So, okay, now that we have this, we can go back a bit to the tabular transformation tab. So here you can see we've added a couple of steps which correspond to the reconciliation of the actual entities. Yeah, first let's find out. Okay, so first thing we want to do is actually extend this data. So now that we have the geonames entity, we can extend with additional data. We currently aggregate weather on a regional level. So we don't have right now the weather for individual cities, but we do have weather parameters recorded for regions. So what we can do is actually extend with data from ECMWF, from geonames, and get additional attributes corresponding here. And then in this case, we want to retrieve the parent region of each city. And in geonames, that's the parent ADM 1 concept, so this one. So this will now extend our table with the new column that contains the name of the region, or the identifier of the region, which is Baden-Württemberg or other. Yeah, so here we actually will do some filtering just for the example's sake. So this sample that we have contains data from several regions, I believe. So yeah, so there's several regions here, and we only want one of the regions. So let me zoom out a bit. Okay. So yeah, the next thing we want to do is filter out the data that we don't really need. So there's some also empty cells, and we don't want those. So we'll take just this region, and we'll filter all the rows so we'll only leave the rows that have this region. So you use the filter rows function, and we say like this column should match the text 2, 9, 5, 3, 4, 8, 1. Okay. And then we want only yeah, so in this case, we only have this one category. So this is the category sport, fitness, football, which is already the case. So we can now enrich the data. So with the weather parameters that we would like to use in this case. So as you can see, we have this date column. So the first thing we want to do is kind of annotate it and kind of say that, or define that it's actually a date that is in this column. So we can say it's a date, and then we need to choose the source column for annotation. We'll annotate it as a DVpedia date. Okay. And now we can use this column in order to obtain the weather data. And we do this by using the ECMWF extension. And here we need to define where we get the place. So the weather data, for the weather data we would need, apart from the date column, we need also for which region we want to extract the data. And that we can read from the column parent ADM1, which we reconciled against geonames. And this is the region identifier of geonames. And then we can select a set of weather parameters. So let's select a couple. The weather offset defines whether we want the actual measurement, which would be 0 offset, or a forecast of 1 up to 7 days. So let's select a couple. And then we can select the weather aggregator. So we can get the average, minimum, maximum of these parameters. So we can say, let's get the average and maximum, or yeah, average and minimum, let's say. Then when I click fetch weather data, now we obtain this data from ECMWF, or our weather enrichment database. And when I click apply, now this data will be extended and added to the table. And finally, what we want to do is aggregate, or so we would like to get the impressions grouped by when they happened and in which region they happened, instead of just so these would be kind of duplicated for date and city. And we can do that. So we can add this function after we filter the rows that we don't want. Okay. So we can group and aggregate by date. And category. And then we group the impressions. And we want the sum of impressions in this case. So now we have the sum of impressions per date, per region, per category. I'll just change this to the ID. We would like to have the ID instead of the name of the category. Okay. Okay, I'll just give me a sec. So you can preview. Yeah, so the pipeline is previewable also. So you can select on any step of the pipeline and preview what happened in this transformation up to that step. Yeah, so in this case, we can say impressions, give me the maximum impressions for each date, administered region, and category. Yeah, so now that we have created our pipeline, we have all of the weather data that we want. what we can do is, well, first of all, we can say this transformation to data graph. Let's say instead of fancy X, we call it demo transformation. Save. And yeah, so what we're able to do is download this transformation as, well, we can download the results as RDF in case we have created a mapping, which in this case we haven't, so we just extended our table with additional values. We also generate these ArangoDB JSON collections, so these would be the JSON files that you need to upload to an ArangoDB database, multimodal database, so you can store your data there. The JSON that corresponds to the transformation, and this is used when we scale up the data transformation. So we want this to as a configuration of the scaling up script. Then we can also download an executable jar file, which is basically all of these steps that we have here, including if you have RDF mapping, the RDF mapping, or we can just choose to get the CSV transformation. And this you can run offline with this command, java jar, and then the name of the jar file, name of the input CSV, and name of the output file, which in this case would be another CSV. And yeah, so data graph would compile, generate this jar file, and then you can run it offline. And the idea is that since this is an online application, there's certain limitations about how much data you can reasonably put in your browser. And then above that, basically you can't really work. I mean, the browser itself will start to be slow, and it would be a bad user experience. So for cases like that, we use these data transformation jars, and then you can run these offline on larger data sets. And that's more or less it for the demonstration. We can run the jar file on a bit of a larger sample, but that's kind of not the point here. You get the idea.